That's rough. Well, let's start. I always think it's funny when I say that, but let's start so we can finish. You know, that's what we should do. So let's do roll first. Bridget.
Here.
Yeah. Elise. Elise is not here right now. Morgan.
Here.
Hey, Haley.
Here.
Haley Guchez. Yeah. Samantha. There. Grace. Yes. Hello, Grace. Are those pumpkin lights? Are they just orange? They're just orange. Okay. Not that there's any judgment. You can have pumpkin till whatever. April Fool's, fine.
These lanterns.
Oh, those are nice. Tarshana.
Here.
Here, there you are. Claire.
Here.
Okay. Leah. Now I'm doubting myself. Here we are, like 2 weeks away from the end. Say it again.
It's Leah. You were right the first time.
Okay. And then I just didn't trust myself. Haley Potter. There.
Here.
Izzy, right there. Miranda.
Here.
Is right there. Daniel. Oh, Elise is here. Hello, Elise.
Hi.
Daniel, I don't think is here. Jasmine. Yeah.
Here.
And Grace Sweet is right there. Hello. All right. So quick reality check. Oh, hello. It helps if I press the right button. We have gone over this in our student meetings last week, which was great, spending more one-on-one with you guys. But just so we have everything planned out, you guys should have started deploying your surveys by Monday. If you have had difficulties doing that, please do reach out. We want to make sure that we can get some data collection put together because we just have a couple of weeks of data collection before we meet again. Make sure, and we've talked about this in all of our groups, but please make sure that you are including some sort of, it's not a consent form, but just more of an awareness. My brain is working a little fuzzy right now. Stating that this is only for a course assignment, that it is going to be held confidential and is not going to be published, and that the participant needs to be at least 18 years old to participate. We don't want any minors to be participating in this study because then we need to get adult consent, which we don't. That's just too much for this class. So make sure you have that preamble or somewhere at the top so people are reading it before they start completing your survey. Okay, so here we are. We're going to be talking about simple experiments today. And honestly, if there's time, I'm going to try to sneak in a little bit of confounding and obscuring variable, but we may also just talk about them at large. It's not that challenging like a concept. Then next week, we have our exam. So the exam will cover from the qualitative research experiment that you guys did all the way through whatever we finish covering by today. So it is not cumulative. Although having said that, some of the stuff we talked at the beginning about how to create a research study, for instance, may apply still, but you don't need to be studying before this qualitative week, this week right here, October 7th. So that is the plan for today, plan for next week. We will do as we've done before, and actually this is a good time for me to share this too. Where is my screen? Chat. I finally got a 616 phone number. Very exciting after 6 years of being here. So if you need to get a hold of me, here's my number. I'm also going to post it to our Course Connect page. But as always, or as we've done before, for the exam next week, we're going to all gather together. I'm going to provide some brief instruction on the exam itself. You'll have my phone number as well, where you can reach out, ask me any questions that you would ask as if I was in class. And then the following week, November 18th, we're going to have small group meetings like we did last week to go over what you guys found out from your data collection. My expectation at this point by November 18th will be that you've gathered enough data and have started analyzing it in order to speak to it in your paper intelligently, right? Like to fail to reject your null hypothesis or, you know, confirm or somehow like it goes along with your alternate hypothesis. So again, we're trying to answer the research question that you laid out in your hypothesis. We want to know if the numbers support it or not. So that's going to be November 18th. At that point, we'll do some final calculations. If there's anything that you guys need me to work on that's like more complex in terms of stats, I will do that for you guys. And then the November 25th, there is no class because we'll all be eating turkey on our own in our closet in the dark. No one touch me. Maybe stocking up on toilet paper again. Who knows? There was like none when I went to the store the other day. I don't know if that's turning into a thing again. Anyway, didn't mean to be so doom and gloom. It's Thanksgiving. That's exciting. Okay, so we're not going to be together. And then after that, it's going to be the final research paper that's going to be due. And I'll provide a specific date. Again, you guys know by now, I'm not really harsh when it comes to deadlines, like, oh, well, now you'll lose all these points. I'm totally willing to work with you guys if there's challenges that are coming up. Just keep me in the loop as always. So that is the schedule for the rest of this semester. Any questions, comments, concerns? Anything that could help clarify? No?
Hello.
Hello,
is
Daniel.
it okay if I email you to set up a meeting?
Of course.
Zoom? Okay, thank you.
Yeah,
I just wanted to ask
no
that.
problem. Yeah. And thanks for bringing it. I'd marked you absent, so thank you. I don't see everybody. I collate it when I share my screen. So, okay, all right. So that is the plan for that. If you have any questions in the meantime, please do let me know. For today, let's find. Why can't I find this spot? That's weird. Simple experiment. Sorry, guys. It's like right here, but I can't find it on the. Okay, here it is. I have too many windows open, apparently. Couldn't find it. Okay. So, here we go. Simple experiments, which this is what this whole class has been about, right? How do we go about setting up experiments, designing them, all of that. So there's two specific examples that are detailed in your text. One of them is in regards to the color red and achievement, and the other one is to eating pasta. And I can see something went a little wonky with the slides here, because anyway, that's fine. So we're going to talk about how we determine experimental variables, why experiments can at times support causal claims. This is, again, when you're doing a specific type of experiment. Not all experiments lead to causality. We'll talk specifically about the three areas of causality, which is temporal precedence, internal validity, and then covariance. We'll talk about independent group designs and within group design, and then we'll look at the four claims of validity. So some of this is we've discussed before, especially in regards to validity. So this is going to totally bug me, and I can just tell. Okay. I know somebody sent me something in the chat. I will look at it in a minute because it's recording, and I'm concerned I will show that to everyone if I look at it. So, okay, hold on to that thought. So the first example is seeing red. The second example is eating pasta. So what are those experiments about? The first one is about seeing red. The idea set out by these researchers is that academic achievement could be tied to the color red. It's this approach avoidance theory. So you can work towards, so approach avoidance. Is that something you guys have heard of before in like basic psych classes? You approach pleasure or seek pleasure, or you work hard to avoid pain, kind of that idea. So if you put that in the framework of academia, you work hard towards success, or you avoid certain task because you're trying to not fail, right? And so that plays a role into this kind of the construct of anxiety and awareness of inferiority, especially if you're failing to move forward into achievement because you think somehow you're inferior. So the researchers' hypothesis was that if you expose students to the color red on a test booklet, it'll cause a worse performance. So somehow that would impact their ability to perform on the task at hand, specifically the academic task that's being required. So the way they did that is they had their participants solve anagrams for 5 minutes, and they looked something like that, like a mixed up word. They had to figure out what it was. And then the ID number on their booklet was written in red, green, or black ink inside the test booklet. Now, in other experiments, participants completed vocabulary analogies or math problems. And then again, on the cover of the test booklets, it was either red, green, or gray. So we're looking at, again, the ink color, right? Whether seeing an ink color leads to worse participation or worse performance on a specific task. Now, right away, I love these kinds of experiments, and I'm like, well, what if someone's really good at math? Is that going to capture this in here? Right? There's no pre-post test. But anyway, the goal is not for me to poke holes at their study. Hold on one second. My little pooch wants to come in. Come on in, little pup-la-poo. Okay, so seeing red. You can see here, these are the 3 tasks that were given. You've got math, vocab, and this is anagrams. So if they were given a black booklet, this is how well they did. This is the number of correct ones. And you can see red is way down here. By the way, that's supposed to be red. It looks orange to me, but it's red. Again, similarly here, we've got the number of correct items for the booklet cover color. And you can see that those who received the red cover performed worse as well. So what do we think about that? That seems like there's a pretty evident, so here's some of the notes they wrote here. Overall, all the students who received red booklets and all of this performed worse. I don't know. What do we think about that? Is that a weird phenomenon? Do you guys feel like you see some validity in that? Have you experienced that?
My science teacher in high school was really picky, and he wouldn't let us use red pens to take notes because he said that we associate it with being wrong. So we were only allowed to use red if we were correcting something. I don't know if that's along the same lines.
That's exactly right. I think that's part of the theory, is that there's an association that's being made, and somehow psychologically that's getting into your head before you even take the task. So kind of an interesting phenomenon. All right, this one I think more people relate to. So this is an experiment about eating pasta in the size of bowls. So there's 2 different conditions that are being presented. There's the large bowl and the medium bowl condition. The participants then served themselves pasta, and researchers recorded how much was served and how much was consumed. Do you guys see where this is going already? Yeah. I feel like this is like probably Weight Watchers 101, where you go from like a dinner plate to like a dessert plate. You're like, you only put food in this size, right? Because psychologically, you're like, I'm still filling my plate, but then it's going to be less food. Anyway, I skip ahead here. So here's the example. So this is the medium bowl versus the large bowl. This is the pasta they had served themselves. So you can see that in the medium bowl, they served themselves a lot less pasta than in the large bowl. And this is how much they actually also consumed. So the difference again between the medium bowl and the large bowl. So again, this is the idea that you're gonna shovel more food with however much space that you end up having on your plate, which, I don't know, tangent perhaps, but that's like fact of life. I think we do that with our own schedules. It's the more free time you think you have, the more you fill. Anyway, all metaphorical right now. All right, is this all people are on board with it, with the medium bowl, large bowl? That's tracking? Okay. Sorry, our neighbor's dogs are barking, so of course our dogs are also barking. Just a whole symphony of barks. All right, experimental variables. So an experiment is at least one variable that's being manipulated and at least one variable that's being measured. So that is how we define just an experiment at large. This is specifically here, we're talking experiment, not just study or research study, it's an experiment because you're actively manipulating one variable. Now, the manipulated variable, the researcher will assign participants to a specific level or value of the variable. Now, this idea here, the researcher will assign participant, you try to do that as randomized as possible. The goal, again, if you're thinking now, let's take an experiment where you're testing a drug. There's this new drug that's been shown to be really effective in treating a certain disease. How would it look if you're like, I'm gonna assign only the women to get the magic pill that'll make them feel better. The men can, just, sorry, Daniel, but just, whatever, right? Or only the young people, only the old people, right? We don't want to be seen with any bias. So it should be a randomized assignment is the bottom line. The measured variable, what that ends up being is the researcher then records what happens in terms of behavior and attitude that's either based on self-report from the participant, behavioral observation from the researcher, or some sort of physiological measures. So let's remind ourselves, this is a question that a few of you got wrong on the exam. What is a physiological measure?
It's something that you can measure physically. Like
That is a great definition using, so what would that be? What would be an example?
Like when you have the little leads attached to your brain and they're measuring like brain waves and stuff.
Totally. Yeah, that would be one. Are there others you guys can think of?
Isn't it like sweating? Isn't that an indicator of something?
Totally. Yeah, when you're feeling anxious or nervous, you'll tend to sweat more. That'll definitely be one. Heart rate is another good one, right? Blood pressure. Those are things that'll get impacted by your own psychological level of arousal, so to speak, or emotional arousal. So measuring those physiological measures will also be important. Now, we can think also of experiments as being done in the medical world or the more harder sciences, right? So for that, a physiological measure may look very different. It could be something like weight. It could be a level of hormone via blood test, right? Something that's physiologically driven. Again, not just self-report. All right, so we've talked about this quite a bit, but you're looking at independent and dependent variables. So again, the independent variable is the variable that's being manipulated. The researcher then has to, that's not a good sentence. I don't know what my brain was thinking there. The researcher has to assign the independent variable to participants, so they get placed into different conditions of that independent variable. So what was the independent variable in the seeing red experiment? What do you guys think?
Is it ink color?
Yeah, absolutely. Ink color or cover color. It's which of the color groups. And what about in the pasta example?
The size of the bowl.
Yep, exactly. The dependent variable then is the measured outcome variable. So in the seeing red experiment, what was the dependent variable?
The test score? Or
yeah, so their
achievement
performance on the
performance?
task. Yep. Yeah, the total correct they got either on the anagrams or the vocab test or the math test. And how about for the bowl, the pasta experiment?
How much was served and consumed?
Exactly. So calories consumed and how much in weight did they actually put on their plates. Okay, control variables are any variable that the experimenter holds constant. So again, this is something that I just finished spending like 3 hours talking about control variable and statistics. It's something that you are trying to take out of the equation when you're looking at the relationship between two variables. So it seems fitting, right, with the elections being yesterday and ongoing for who knows how long at this point, not getting into the weeds of that, but a control variable could look like, one of the examples we were talking about, is if I'm trying to figure out if age plays a role in voting behavior on immigration laws, right? So maybe my hypothesis is that the older you are, the more stringent you are on immigration law. I'm making stuff up here. But there could also be a confounding variable or a variable that's underneath that that would explain away that relationship better than just age. Do you guys have any thoughts on what that might be? Like, can you think of another variable that would be a better predictor than age in predicting views on immigration law?
I guess whether you are an immigrant or your parents were.
Okay, so yeah, that could be one. So your own origin. So whether you're foreign born or national born, I guess that is right? Foreign born or national or locally made. Anyway, let's not say that. You know what I mean? Okay, yeah, that could be one of them. What about political party or gender, right? Like, or education level or income. Those are all other variables that may very well play a strong role as to how somebody feels about immigration laws. And in fact, if you were to control for that variable, the relationship that we previously saw maybe between age and immigration laws, that may go away altogether. So for instance, if I'm looking at, again, age being a significant predictor or having a significant relationship with immigration laws, but then I want to control for political party, I would then divide, so you do a bivariate table, sort of we were describing, you divide the group so that you're looking at age and immigration law views for Democrats over here, and you look at age immigration views for Republicans over here. And then you see if the relationship is still as strong once you're only looking within the same group. So we'll talk about same group differences too. Anyway, so those are control variables. That means you are taking away that potential variable as explaining away the relationship between the other variables. Okay. Now, why can we bring up causality with experiments? Now, a few reasons why. First is that experiments establish covariance. So if there's levels of independent variables that are related to different levels of dependent variable. So for instance, on the seeing red, we had different levels of our independent variable, right? It was red, gray, and green, I think. Perhaps if we made that into a category for the dependent variable, that could correspond to different levels. So that we could not only say that red led to a worse performance, maybe we could also say that gray led to a higher performance somehow. We divided up the scores again. So you can look at covariance between different levels of your independent variables. Next, they establish temporal precedence of what came first. In this instance, the independent variable comes before the dependent variable. So again, I'm giving you a booklet that has a color on the cover. That happens before your performance. So one leads to the other. There's temporal precedence. And last, well-designed experiments work hard to establish internal validity. So that means there are really very few other alternative explanations for the results. It is internally valid and works together. Okay. Now, experiments, I'm going to break up these as I was talking about earlier in the three different categories. First, they establish covariance. So independent variables answer compared to what? Like it's a comparison group. So if I'm comparing red, green, and gray, or medium versus large, or Republican versus Democrat, or right, like I'm comparing different groups. That's the independent variable. That's what it's predicting or how it's relating to. Covariance is also part of the outcome. So for instance, the amount of pasta that was eaten, that's part of the covariance in there. Now with control groups, like as we talked about, they're not part of the treatment condition. It's something that is maybe an extraneous variable that you're trying to make sure that is not taking part of the variance of the whole relationship of the independent variable and dependent variable. There could also be a treatment group. So if you think about drugs, right? A drug setting, if you're doing like an experimental drug, there's going to be a control group that gets nothing to see what their results looks like. There's going to be a treatment group. They're getting a specific, that's actually what's being tested, right? The specific drug. And a placebo group, they're getting something. It's actually nothing, but we want to make sure that just taking a pill in and of itself is not going to improve their symptoms in some way, because psychologically it feels like they're doing something. Okay, does this all make sense? I feel like we've talked about this before this semester, but I want to make sure we're all on the same page. Good to go? Okay. Now, experiments also establish temporal precedence. We've talked about that just a second ago. So the cause variable comes before the effect variable. So again, in the pasta study, we talked about the seeing red study in a minute, earlier, the experimenters manipulated the independent variable, whether they got a medium-sized bowl or a large-sized bowl, and then they measured the dependent variable afterwards to ensure that there's a causal precedent, that there's something, right? So you get the bowl size, and that impacts how much food you get. Now, when you're looking at correlation, right, what is the relationship between two variables, you cannot determine which variable comes first. It just states that there's a relationship. With experiments, you can actually say, no, this happened first, which then led to that. Okay, does that make sense? So again, temporal precedence, what happened first? And then lastly, internal validity. So well-designed experiments, they work really hard to establish internal validity. So when we're thinking about the experiments we discussed, we are making sure that there is no confounds within our study or confounding variable. That's a third variable explanation that is more significant than what you design in your experiments. So you need to just be thoughtful about that too, right? So if somehow the medium bowl people were offered, I don't know, what's something that's gross? Pasta with, I don't know, what's something that doesn't taste good with pasta? Some sort of less favorable pasta. Let's say it was a no cheese, vegan, no meat. I don't know, maybe that's appetizing for some people. So now let's pick something totally weird. There's pasta and brownies mixed in with fish, right? You're like, okay, well, I got a medium bowl. I'm not going to put a whole lot in it, but also I'm not interested in the food. And then the people with the large bowl, you give them the nicest spaghetti ever on the face of the planet. Well, they're putting more in their bowl, maybe because their bowl's bigger, but also the food is more appetizing. So if you're giving different types of food or different quality of pasta, that's going to impact the study. But that's not what's being measured. So it's considered a confound. It's something that is not actually measured that is going to impact your study. And you're not only not measuring it, you're not really aware of what's happening. So that's a definition of a confounding variable, something else that's under there. Does that make sense? Okay. Another idea would be, well, we'll talk about it more later on in the lecture, but this is a good introduction. You want to watch out also for selection effects, because then if you, for instance, let participants choose between a medium bowl and a large bowl, you may have a totally different study, right? Let's talk about that. Why would that be impactful if you let people choose between a medium bowl and a large bowl?
I mean, depending on how hungry they are, might sway their option of going for one or the other.
Totally. How hungry they are, maybe how full they are, right? How about have any of you guys been on a date and you're like, I'll just have the small side salad. I don't know why I grabbed this as if I'm going to eat my pen, but like maybe there's some sort of societally approved or you're concerned about how you'll appear, right? Like trying to save face or like, well, I'll just take this little one, right? So there's other factors that play a role if you just let the participant choose. And it's also important, as I mentioned earlier, that you're choosing our assignment, the different conditions, be randomized, because you want to make sure that you're not going to be picking one specific type of person to get one specific kind of condition. That would not be appropriate either, right? I'm going to pick the ones who are, normal or like average weight or underweight or overweight to this particular category. You're messing up your own data by doing that. Don't do that. Okay, design confound. So that is something that very much threatens the internal validity of your study. Because if you have a confound that is going to impact your results and you're not measuring it or addressing it in any way or not seeing it as a mediating variable, something like that, it is going to very much impact the results and the validity of your results. It can make it so that a causal claim for your independent variable is extremely challenging because there's something else happening in your study that you are not in control of that is going to impact the results. The problem that's also seen is systematic variability. So that is variability within one independent variable. For instance, having red ink and the difficulty level of the task. So depending on that, that could impact it too. So I think I have a good description here. Oops, where is it? So this is specifically with the one with the bowl group. If those participants in the large serving dish group had higher quality pasta, like we talked about, than those in the medium dish group, then that's a systematic variability and it's a design confound. So that is problematic, right? It is something that's going to impact your dependent variable, but that you are not actively measuring. It's just happening. The unsystematic variability is random, not a confound, but can dilute effects of the independent variable. So a random or haphazard effect in both groups. So it's not a confound, it's just present. So for instance, if folks really just are having a hard time solving anagrams, that's going to be impacted in all different levels of your independent variable, whether it's a black cover, gray cover, or red cover. But that's going to cause some impact. It's going to reduce the effect of your independent variable because that everybody else's scores are going to be lower, right? So that is problematic as well. Okay. Whoops, that's what I meant to do. No, thank you. All right, so what is a selection effect? Selection effect is when you are, hold on one second. I'm gonna bring her upstairs because there's a lot of barking and I can't, yeah, come on. All right, sorry about that, guys. Okay, selection effect. By the way, you all got to see my nice new backdrop. I'm very excited about it. I got the cubes from Target. All right. So
really fast, I just want to say I have like an 11-week-old puppy, and every time your dog barked, she like looked behind my laptop to figure out where it was coming from, and it was impossibly cute. So thank you for that. I needed that.
Well, I'm glad that worked out. It was driving me bananas. Our puppy's upstairs, and then somehow she was barking at my door earlier, the older dog. Anyway, it's a long story. Well, glad I could make that night. All right, so again, what is a selection effect? That's when you are assigning the experiment. So it's an experiment where the participants in one level of the independent variable are systematically different than the participants in the other levels of the independent variable. So somehow you've selected so that one person is getting one treatment versus another. So the example that's right here is by Lovaas. He conducted a study to test an intensive therapy for children with autism. Some children in the study received the new treatment and others continued their usual treatment. However, they were not randomly assigned to these groups because some families lived too far away for the intensive treatment and other families requested the intensive treatment. So the researchers found that the autistic symptoms of kids in the intensive treatment group showed more improvement than those in the treatment as usual group. But really begs the question, was there a selection effect as to the families and where they selected, right? Being further away and not being able to participate. So it's impossible to determine the reason why there's an improvement because there's been a selection effect. So the only way to really eliminate selection effect is random assignment, as I was talking about before, so that someone has an equal chance to be in one treatment group or the other, that you're not letting the participants choose, and you are not choosing like, well, I'll just have them do the, treatment as usual because they're really far, or they have 4 other kids, so they don't have the time for the intensive treatment. You're removing any of that potential bias and just randomly assigning, which obviously is going to be the strongest experiment that you can do. Okay, so unsystematic variability, again, let's talk about that, is different than a confound. So some people, for instance, this is unsystematic variability. Some people love to eat pasta, others don't like it at all. The same way, like if you're doing an example with a cereal bowl, some people don't like cereal, other people love cereal. But individual differences don't become a confound unless it's one type of people that end up in one group systematically more than another group. That's when it becomes a confound. Individual differences that are distributed across both groups, that's just what's considered an unsystematic variability that's just seen throughout the project. So as you can see, there's variability in both groups, should be about similar. Okay. Avoiding selection effects also allows for us to have matched groups. And the reason why we want matched groups is that we are actually comparing mostly even groups, which is kind of the goal. So in these 3 specific groups, you can see that there's a mixture in terms of IQ. This is a particular test that they did. So that across the board, you've got the really high IQ folks that are spread out in all 3 categories, but you also have the 3 lowest IQs that are spread out, again, in all 3 categories. Just makes it so it's more evenly distributed and you're actually comparing the groups in a way that's meaningful. Okay, next step is independent group designs versus within group design, and then we'll talk about post-test, pre-test, and post-test design and which one is better. So let's start with the first one. So independent group designs are between subject designs or between group designs. Those differ from the just straight up within subject design. So let's look at this graph. That'll make things a little bit easier. Oh, no, it's not. Sorry, that's my next one. Let's see what else I want to tell you about that. Independent group design. Different groups of participants placed at each different levels of IV. We've done that. To the larger bowl within group, design with all levels. Yeah. This is fairly self-explanatory. So looking at the different groups or all the levels of the one group. Okay, so then post-test and pre-test post-test. This is important because oftentimes when we talked about temporal precedence earlier, having established, and this is what I was hinting at earlier with the ink color test, is if you don't have a baseline of the person's performance or a pre-test, then it's hard to know if the color of the ink played a role at all, or if you just got some random assortment of poor testing, right? So if you did a pre-test on their ability without any color and some sort of post-test with the color and you saw they performed worse and they were equally matched in difficulty level, I think that would be even more meaningful in terms of the design. If you're doing a post-test only, this would be exactly the way the study was designed. So you're randomly assigned to one group or the other, right? Independent variable group 1 or independent variable group 2, and then you're measured on that dependent variable. This is exactly the same. You're randomly assigned to the red ink, green ink, or black ink group, and then you're performing on this task, the anagram, right? That is a post-test only design. The pre-test post-test would be this. You're randomly assigned to one of 2 groups. You're given a performance test on anagram, just like I was describing. Then you're exposed to the color red, and then you do the anagram test again. Or if you're in the other group, anagram first, exposure to green, and then the anagram performance. So you're allowing to see if there's something to do with their just challenge in completing anagrams, period, whether that's part of it. So if you do the pre-test before that, then you can speak more eloquently as to their performance on the post-test. And if there is a significant dip, then you can say that's the impact of seeing the color red. Pre-test, post-test, good to go on that? Makes sense? Okay. You guys have access to all these slides too, so hopefully you're not freaking out if I'm going too fast. Okay. So this is another example of a pre-test and post-test. So it shows this is a study by Mueller and Dweck from 1998 that it can use, they use a pre-test and post-test design that can be used to track changes over time. The participants were fifth graders, and in the pre-test they solved fairly easy puzzles, and their performance was similar in both groups. Then the independent variable was presented. Children received either one of two types of praises. Process praise, like, wow, you must have worked really hard on these problems, or person praise. You must be smart to be able to complete these problems, right? Two different pieces. Then all children were asked to solve a second set of problems that were meant for 10th graders to provide them. So again, fifth graders not going to perform really well with the 10th grade kind of problems. But the idea was, how are they going to experience the sense of failure? Then the children were given a third set of puzzles similar to the first set, which was then the post-test. They found that kids that received person praise showed a decline in performance, whereas those receiving process praise showed an improvement. So here it is noted, right? You've got the first pre-test and the post-test, and what was introduced in the middle, right, was whether it was the kind of praise on the person themselves, you must be smart, versus the you must have worked really hard. And then you see the impact then on the performance. So just good take-home message there to always praise process. So if we think about all these designs, which one is better? And there's no clear-cut answer. It really just depends. In some situations, it's problematic to use a pre-test, post-test design. For instance, the eating pasta one. Why would that be problematic to do a pre-test and post-test? There should be a kind of an obvious answer on that one. What do we think? Anyone? What would be a pre-test for the eating pasta one?
It would probably be them like eating on one size plate and then eating on a different size plate later, which
Yeah,
could,
and why
like,
would that be problematic?
if they're doing it in the same session, it would be problematic because they could start to like fill up on food and not fill up their plate as much as they normally would. Or
Exactly.
like having been exposed to both sizes of plates could prime them to like react a certain way or have certain results.
Yeah, you're absolutely correct. If you're doing any sort of food experiment and then you're seeing how much food they're going to put on their bowl and how much they're going to eat, and then you tell them something, you're like, now I need you to queue back up into the buffet line and now grab the other size bowl and let's see how much you eat. Like, someone's may not be hungry at all after that. So that's problematic. But in another situation, a pre-test and post-test design makes the most sense. I would actually say that the ink one would be a good one to do a pre and post-test. And same with the person versus process praise. Then you see how they respond to the challenge of not, they're not performing well, they have a failure, but how do they take the praise and how does it impact their score? But it's important to note that post-test design can also just in and of themselves be really powerful. It's not because you're not doing a pre-test that your design, your experiment is no good. There's just good reasoning behind doing a pre-post test in certain circumstances. Okay, then we can look at within group designs. Those are the two types. So you've got within groups, you have concurrent measure and you have repeated measure. Those are the two differences. Concurrent measure is that they're happening concurrently at the same time. Repeated measure is you do the same thing again and again and again to see if there's any difference. So this is one of the advantages of doing within group design is you're really taking away any sort of variance because you have a different sample taking the test. You take out that variability that like, well, it's a different group. Maybe they just perform better or they responded differently. The advantage, obviously, then when you're within the same group, you take that variability away. It speaks more to the treatment, whatever's being introduced as a condition. Excuse me, with that, you can look at covariance, temporal precedence, and internal validity, just like we talked about earlier today. Those are all present. There are some disadvantages, though, with doing within group designs. It's a little harder to have a good sense as to what it is. So let's dive into each level. So first is a concurrent measure design. So this specific study in your text is kind of interesting. It's the own race bias in infants. It uses female faces and same race as infants, and then other race as infants. So the concurrent measure design states that participants are exposed to all levels of the independent variable at roughly the same time, and a single preference is the dependent variable. So the example is about looking preference, and this is specifically infant research. So they're exposed to both. Which one do they prefer? So they're exposed concurrently. So you'd have both faces, and then you're marking which side the infant is looking at. So what is their specific preference with that? A repeated measure would be doing it again and again and again. So this is a repeated measure design for within group. That specific one by Bick and Dozier studied the influence of the hormone oxytocin on social bonding. This is a hormone that's released during birth and breastfeeding. So the participants were moms and their toddlers. Participants interacted with their own toddler, and then oxytocin levels were measured in the moms. Obviously not through breast milk for that, like you can do that just via blood test. And then the moms then interacted with a new toddler, and oxytocin levels were measured again. Oxytocin levels were then higher with the new child than with their own toddler. So they were higher when women were, with their new child. So you're doing the same thing. So it's a repeated measure. So you're doing exactly the same thing, just again. So there's one group, you interact with your own kid, measure it, interact with the new kid, measure it. The idea is with the new kid, you are promoting more of that hormone to try to bond more with them. There's already bonding that's occurred with your toddler at that point. Some of the advantages of within group design, obviously participants in your group are equivalent. I just talked about that. So you're reducing variability. So you can use them kind of as your own control. It gives researchers more power to notice differences between the conditions because it's the same group. And it requires fewer participants. You don't need quite as many to have them go through all of the conditions. So that piece is pretty huge because research often focuses on ways to be as efficient as possible. In terms of covariance, temporal precedence, and internal validity, you have the order effect. The fact that it's this, then that, then this, then that, that gives you temporal precedence right away. So again, you can randomly assign two groups. One will interact with the new toddler first. The other group will interact with their own, whichever one I said. So one is own, the other one is new. Measure oxytocin, then swap it, right? Old and new. Measure oxytocin to see if that maybe has an impact. If seeing your own kid first impacts the results later on. So you can avoid that order effect by counterbalancing and swapping it. So it just gives you a lot more flexibility as a researcher to try to eliminate compounds. Again, that is the name of the game. You want to make sure that you have as valid of a study as possible, and that the relationship that you discover or unearth is actually the true relationship, that it's not due to another factor. Okay. There's not a whole lot of questions, or so I just want to make sure, are we all good? This is not a very long lecture, so I was just planning on keep going if that's okay with everyone. Okay, please speak up. Otherwise, I've got you guys all minimized, so if any of you go like this, I'm not going to see you. Okay, so independent group designs, that is when you're actually splitting things up, right? So you've got randomly assigned, right? Got 100 people, 50 of them interact with their own toddlers, 50 of them interact with a new toddler, and you measure oxytocin. There's some advantages to that, right? Like you can, well, this is independent group. I feel like did I go backwards? No, there it is. You can take a look at that and see what is the impact, but if you're not comparing it, again, like we were doing earlier, the concurrent event, it's hard to know then what is a high level and what is a low level, right? Okay. So some of the within group design, advantages is it minimizes within group variability because each participant is being compared to himself or herself. In between group designs, we're comparing different individuals. The oxytocin example, maybe somebody just produces really high level of oxytocin. If they're put into this independent group design, you wouldn't be able to know whether that's an independent effect, like that's just that person, or whether that's because it's a new toddler, for instance. So there's some limitations with that. Okay, again, the order effect, if you're exposed to one condition, affects how participants respond to other condition, that will have an impact, right? So again, in our oxytocin experiment, if you're able to swap it and then you compare to see if they're still the same type of results, if being exposed to the new toddler still has higher level of oxytocin, whether they're exposed to them first or second. Practice effects are a big thing, especially if you're looking at performance. I'm thinking of the ink cover test, for instance. If you're having somebody do a similar task over and over again, there is going to be practice effects. They may just get better because they're exposed to it more often, or the reverse could be true. They get fatigued. They're like not caring. They don't want to do it anymore. They're over it, so their performance is going to be declining. And it's not because of the independent variable that's at play here. It's just because they're fatigued. So we need to keep that in mind also when we're doing order effect and concurrent stuff. Carryover effect, if you do the drug and the test and then the placebo and the test, you need to be really careful because half-life of drugs, especially when you're doing a drug experiment, can take a really long time for them to leave their body. So once you're doing a placebo test, you might actually be seeing the effects of the drug still because it hasn't left their system. So you need to be mindful of that. Okay, so counterbalancing is obviously the way to go to avoid order effects. So there's full counterbalancing or partial counterbalancing. So if you're doing full, as described over here, it's when all possible condition orders are represented. So you could do A, B, and C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. That's a lot of different variability, right? So you have them all done to make sure that you're not seeing a result because of the order that's taken place. A partial counterbalancing is only when some of them are being used, some of the conditions. So you could present a randomized order for each participant or a Latin square. Each condition appears in each position at least once. So again, this would be partial counterbalancing, right? If that's the order, 1 through 6, then there's still 6 possibilities and you just swap them in terms of places. But obviously this is not every single option, right? Because that would be doing a factorial, 6 factorial, isn't that? That would be a lot of different trials you'd have to run. No one's got time for that. All right, disadvantages of within group design. So there's a potential again for order effects. We can solve that through counterbalancing. It may not be practical or possible. So you think about patients again with cancer, or if you're doing some sort of permanent change, or the ethics involved of within group design, like them may not be the right fit for everyone. And experiencing all levels of the independent variable changes the way participants act. Just inherently, there's going to be demand characteristic that is present, which is when participants pick up on cues that lead them to guess to the experimenter's hypothesis. So when you're working through those several times, you know, that it impacts it, because then all of a sudden you've just introduced a potential bias that's within the relationship of participant to researcher. Anyway. Oh shoot, I got cut off a little bit. Let's see. Pre-test and post-test of a within group design. So if they're randomly assigned to a pre-test, then you expose them to independent level A, then a post-test, or within this one, so this would be the same idea, but with level B, then you measure a post-test. So that would be a pre-test, post-test. If you're doing a within group design, then again, you can do a repeated measure that way. So you've got exposure to A, you measure it, exposure to B, then you measure it again. Then you reverse it, right? Exposure to B, measure it, exposure to A, measure it. So that would be, again, your repeated measure to assess that particular within group design. All right, so here's the 4 validities again. Hint, hint, might want to know that again for the exam. Construct validity is how well things were measured or manipulated. We'll talk about those in just a minute. External validity is to who or what can the causal claim generalize to. Statistical validity, does this data support actually what our claim stated? And then internal validity is asking, is there any alternative explanation for the outcome? So diving into each. Construct validity. How well was your dependent variable measured? Is there any sort of room for error right there in the measurement of the construct? Similarly, how well were the independent variables measured, right? You had to manipulate one of the variables. How well did you do that? You know, how did you actually make sense of that? And then one good way to do that is to do a pilot study. A pilot study is kind of a practice run of the experiment that you want to run, so that you learn from a smaller sample set whether the effect that you think will happen in your experiment is actually present. But it does it on a micro level. It's just a little easier to take a peek before you dive in and spend months collecting data. So that's one good way to measure and practice measuring your independent variable. So this is construct validity and theory testing. These are the number of easy items that were chosen and then the booklet cover. So what does that tell us? If we take a peek here, if we're making you know, a specific booklet of different hardness level or different challenge level, that's going to impact our study. So if we take a peek here, it was what describe. One manipulating the in color of the ID number, one was the test booklet. Let's see, that's not what I wanted to tell you guys. Oh, that was about warm day. That was a weird little sidebar about like color coolness. And do you guys remember that? Like, this is years and years ago. They were like, I'm a warm color, I'm a cool color. Like, people would identify with colors in their personalities. This is a long time ago. You guys might be too young. But anyway, that was another theory that's something that could have played a role into that. Okay, external validity. Who can this actually generalize to, right? Because whenever we're doing an experiment, we take a small sample, but we want it to generalize, obviously, to the largest population possible. Otherwise, why are we doing it? So we want to make sure that whatever we're doing is not going to be so narrow and focused that it's not going to apply to more people. So how were the participants selected for the experiment? Was it random sampling? This is an example, again, that specific study by Mueller and Dweck that had a convenient sample of 5th graders. One was in the Midwest, the other one the Northeast. So, you know, that's more specific sampling. Is that actually going to generalize to the rest of the United States? Possibly. we'd have to show that the demographic variables within that school are similar to the rest of the country to then make sense of that. Statistical validity, again, does the data actually support a causal claim, the fact that there is a relationship that exists there? So for that, you have to look at effect size. We notate effect size with the letter D, it's an italicized D, and you can see the greater the number, right, the stronger the relationship. It is always going to be below 1, between 0 and 1. And you can see the small effect size would be like 0.2 to 0.4. Medium would be 0.5 to 0.6, 0.7. And then anything bigger than 0.8 is a large effect size, meaning what you received, the data that you gathered, the likelihood that it occurred by chance is very, very small, that it speaks to there being a statistically significant relationship between the variables. And then for internal validity, it's the question, are there any alternative explanations for the outcome that came through? So were there any sort of design confounds that were present, right? Is there another reason why you may have gotten your data because of something that you are not currently measuring or you're not aware of? If an independent group design was used, did they control for selection effect using random assignments and matching? If it's a within group design, did they control for order effects by counterbalancing? That's the way that you keep really strong internal validity within your experiment. Okay. How are we doing? That was a lot of talking for over an hour. We all tracking? Everybody's like, oh, too much stress, elections, freaking out. At least it's beautiful weather today. Yeah, that's to be thankful for. Any questions about experiments? Are we understanding confounds and why they're bad, and that we don't want them?
Just to make sure I do have compounds right. So it's just like, so it is a negative thing that's just like an unmeasured variable that you're not accounting for that'll affect the results, right?
Yes, exactly. Yeah. So one of the examples that was in a different textbook that long time ago that I always liked was measuring tonality and levels of assertiveness. So they had speakers come out and they were measuring their tonality, like how they spoke as speakers, and how people perceived them to be in terms of assertiveness. So the idea being the stronger, louder you eloquate, right, and speak, the more assertive you are. But they had so they randomly assigned, right? They had women speak really softly like this, and they had men speaking with loud, booming voices. Well, what might be a confounding variable here? Gender, right? Like gender plays a huge role. It's not being measured. They're being split, and then they're being assessed on this dependent variable of assertiveness, but they're not measuring or looking at gender when really that's probably the biggest piece that people ended up taking away from it. So something that would be a confounding variable. Yeah. Anything else? I feel like this lecture, there's a lot of repeated material from before, especially when you start talking about validity, statistical validity. Hopefully that's like really like just entrenched into your psyche now to talk about that. Right. Anything else I can be helpful with projects? Any questions you guys have about that? Otherwise, that's all I've got for you tonight. Just good luck studying for the exam next week. Not because it's going to be scary or bad. It wasn't like a mean thing, just extra time.
Quick question from me. So you said that, flip through something real quick. Okay, you said that anything from before October 7th, we don't need to study for this test?
That's right.
Okay. And then,
I mean,
so
I also said some things are like inherent, like you, I'm going to cheat here. I'm going to pull up the exam right now on this other screen, because otherwise, why take a test I just showed to you right now? It keeps going to the other screen here. Here it is. Where are you guys? Here you are. Okay. sampling. Yep, sampling, correlation. Yeah, all of this we discussed those in the last 2 weeks. Know the validities, we talked about that already. Yeah, this exam is pretty straightforward and pretty easy. Think back, so obviously we didn't have a lecture on the 7th. I think the 7th was the qualitative research day. For that, just take a look at the chapter on qualitative research and what are your takeaways from your study and when you presented it in class. Like,
Okay.
not like, what did someone else say? No, I'm not going to do that. But like, what are some takeaways, what you learned, pros, cons of qualitative studies? That would be a good thing to look at too.
Okay. And then you said, so next week is the exam, and then the week after that, it's another like group meeting day.
Yes.
Okay.
Yep.
Just wanted to make sure I had that right.
Yep. No, you're spot on. So yeah, we'll do the group meeting. So it is really, really imperative that you guys are collecting data now so that we have data to analyze and discuss by whatever that's going to be, the 18th, which is when we have our group meetings. Okay. All right. Well, stay well, all of you. Keep healthy. We'll see you next week. And those of you who wanted to email me privately, feel free to also text me, and then we'll go from there. All right. Talk to you guys soon. Bye.